morning, everyone, or good afternoon, or good evening, wherever you may be in the world today. My name is Tammy Bednar. I'm a product manager in the database team. We really appreciate you joining us today to talk about the physical migration of an AWS RDS Oracle database to OCI Database Cloud Service or Exadata Cloud Service. I know that's a mouthful, but it's really important topic, and I'm really happy to have Marco join us today to talk about how we can move databases or migrate databases into OCI. So Marco, welcome, and thank you for presenting this topic to us today.
All right, happy about doing that. Thank you, Tammy. So hello, everyone. My name is Marco Calmazzini. I'm a product manager here at Oracle. And as Tammy mentioned, what we're going to talk about today is the physical migration of an Oracle database from AWS RDS to OCI Database Cloud Service or Exadata Cloud Service. And we're talking about physical migration because this is really a complete, lift and shift of an RDS database to OCI using RMAN backups. So we would not use any log shipping or logical copy method. This is really a complete physical copy of the Oracle database data files from one infrastructure to another. We will have Q&As at the end if you have questions. Otherwise, feel free to enter them in the chat or in the Q&A tool, and we'll go through them at the end. Tammy, if you can keep a look on that, maybe that would help. Thank you. So first of all, okay, why you want to do that, right? OCI is the best best cloud infrastructure for running Oracle databases. All the Oracle database options are available in OCI. You can run an Oracle database in OCI on a virtual machine, on bare metal, or on the Exadata Cloud Service. You can use real application clusters. And basically for all these reasons above, it's easier to use OCI for hybrid deployments, for example, because it's easier to match what you have on premises with what's available in the cloud, right? And I will not go into more details on why specific OCI. This is really, all this presentation is really very technical on the steps you need to take to do that. Okay, and from a very high view, if you want, these are the steps that we need to take. As you know, if you are familiar with AWS RDS, you don't have access to RMAN, you don't have access to the VM, to the operating system where the database is hosted, and you don't have access to to a user with SysDBA privileges. All you can do is use the RDS tooling, use SQL Plus and connect to the instance and use the RDS tooling, or obviously use the console. What we're going to do, we will use the RDS tooling to take an RMAN backup to the RDS block storage. And then we'll use again the RDS tools to copy those backups pieces to an S3 bucket. And then we will copy that backups from the S3 bucket to an OCI object storage bucket. And from there, we will restore in DBCS and XSCS. And I will give you all the details on how to do that. The environment that we used, and then there's this exercise to do that. Okay, so we started from an RDS Oracle, obviously, database, version 19.6. It was January 2020 image on RDS. We have one option group set, which is the S3 integration. I will talk very briefly later about this. Parameter group is the default, so we didn't touch anything, just a standard Oracle database. On a small T3 small instance in OCI, 2 vCPUs, 2 gigabytes of RAM. The storage has encryption enabled, but that's not TDE, and that is one important step, one important thing to consider. And it will come later in the presentation, because the encryption enabled here refers only to storage encryption that RDS provides. Again, it's not Oracle database tablespace encryption. And you cannot have TDE encryption. There is an option of using TDE encryption in RDS. If you have such a database, the wallet is managed by RDS. You don't have access to the wallet. And it means that to move this database to some other location, you need the master key from that wallet to open that database. So if that's the case, what you need to do is you need to clone this RDS instance that you want to move and turn off TDE encryption before you do that. Otherwise, you would not be able to access the wallet and get the key to keep that same encryption on another platform. Okay. On the OCI side, we use DBCS, so Database Cloud Service Instance, also a small instance, VM Standard 2.1. The database version is aligned, if you want. So 19.6, we applied the January 2020 patch bundle on the database cloud service side. We obviously have TDE encryption because that's mandatory in Oracle in OCI, and we have multi-tenant on. So and that's also mandatory in DBCS or XSCS. I mean, in the Oracle Cloud, all the databases, unless you are managing your own database and you create a compute instance where you install an Oracle version and that you do whatever you like. But if you're using Database Cloud Service, Exadata Cloud Service, it is and it must be a multi-tenant configuration. So if you create this instance on purpose, meaning, okay, create a new DBCS service instance or a new XSCS service instance where I'm going to copy my database, then make sure you don't use the same instance name and database name that you had on RDS. Otherwise, you have to then take care about changing it later because you cannot adopt a database that was a non-CDB, like in the RDS version, as a PDB in another existing CDB, which is the one we created in BCS, if there is a name conflict. Okay? So, to make it short, the name of the AWS database must not be either the instance name or the PDB name of the first PDB that you created when you created this system, okay, this instance. So going straight into the process, right, and the steps we need to take. So first thing we have to do a little preparation on the AWS side to start this. As I mentioned, you don't have access to the operating system. You don't have access to RMAN. All you can do is connect with SQL Plus or with another tool, but you have only SQL access with a user which also has no sysdba privileges. So using the tooling that you can, it's basically a set of PL SQL scripts. You prepare, first of all, the location where we're going to take an RMAN backup. The AWS backups that you take using the console or that are that are taken using the automated backup in AWS are not completely RMAN backup. They use snapshots to do that. And obviously those cannot be copied somewhere else in the store. So we need a complete, full RMAN backup. So we prepare the destination using this RDS admin _util.create _directory command, and we specify a directory name. Okay, obviously you need to have some space on disk for doing that, so make sure your block storage is large enough. And we call it backup. You can call it whatever you like. So backup is the name, and this is our destination where we will create our RMAN backup. If you don't have archive log retention enabled, you have to enable archive log retention on the RDS instance, again using this RDS admin _util.set configuration command, and we set the archive log retention hours to 24, 48, whatever time you need to have your archive log retained. This is very important. If you don't do this, the backup would not work. So the result of this command would be, okay, PL SQL script executed successfully. Actually, nothing happens. You go and look at the destination, there is no backup. Okay, so make sure you have this step. You have to enable the archive log retention. There's a link here, and so you will be able to find it later when the slides are posted. Is the link to the AWS documentation where this thing is explained. Next step we have to do is we have to take care of the S3 integration, because we will copy this RMAN backup to S3 in order to be able to then move it to OCI. So create an S3 bucket. S3 is obviously the object storage service in AWS. Create the S3 bucket, which will be the destination for copying the backups. And there are a few more things that you need to do, because again, this copy process will be initiated by the tools in the RDS instance. Again, you don't have directly, the ability to log into the instance and do anything. So you need to grant the privileges to the RDS service to copy these backups to an S3 bucket. And again, you have the link here with the documentation with a complete step-by-step example of how to do that. But yeah, in short, you create an IAM policy to allow the RDS system or service to access the S3 bucket. Okay, the S3 bucket that we created here. With the appropriate action, you have to create an IAM role, associate this IAM role with the RDS instance you're working on, and then you associate the RDS instance with the option group that I showed before that has the S3 integration option. And this will basically grant the RDS service the privileges to write into your bucket, the bucket that you created before. When this is complete, we are ready to start actually taking the backup, so start the backup. Again, there's RDS admin underscore RMAN underscore util package, and what we're going to use is the backup database full. This will obviously create a full backup of our database. The owner will specify sys. The directory name is the backup location we created as the first step. So this is where our backup will go. Again, it's on local block storage. It's not S3. We include the archive logs in this backup. You can specify the number of channels based on the size. You can specify compression if you want. Again, you don't have the advanced compression option in RDS, so the only compression algorithm you have available is basic. So if you set it to true, it's basic compression. If you set it to false, which I think is the default, has no compression. You can specify a section size if you want. I think this is also option. And this output, you can set it to false or true. I set it to false, and the RMAN output would go into a log file in the bdump location. I will show it later how to read it. Honestly, I tried setting it to true, nothing changed. So I left it to false. And that's it. I mean, yeah, sorry, go ahead.
No. I was just going to say, there was a question that came across. Rashmi says, when we create a directory backup, what would be the size that would be allocated to the file system?
I don't think it's allocated as size. It will provide you a location. Okay, so you have to make sure you have enough space based on the size of your database. So consider that you need to store a full backup of your database on local disk. So the size, yeah, it depends on the size of the database. But it doesn't give you a size. That command only, it's like running an mkdir command on the operating system. It just creates a location. Okay.
So you need to allocate as much space as but with the RMAN backups, you only back up the blocks that are used, but in this case, you have to back up the full database, even the empty blocks, or is that different?
No, I think optimization is on. That's a good question. Honestly, I didn't check how they did, because again, you don't have access to RMAN, so you can do it run this command. But I think optimization is on. So I'm almost sure the unused block would be skipped.
Okay, perfect. Yeah. There's some more questions coming through while we're here, Marco.
Yeah, go ahead.
Share your thoughts on, for example, on grid infra versus logical volume manager, when to select one versus the other?
Yeah, sure. Well, obviously it depends on the use case. So here in this example, to make it simple, I just use LVM I went from an LVM environment in AWS. And by the way, I think it's only you. No, you can use ASM. But anyway, I went from an LVM environment in AWS to an LVM environment in Database Cloud Service. I didn't use ASM. Obviously, if you're going to access Data Cloud Service, I mean, you have to use ASM, right? The point is that if you go from LVM to LVM, like in this case, I don't need the extra space in the Database Cloud Service side, and that was the reason I wanted to keep it simple, and I just stayed with that, because when we do the restore, we can restore obviously to the local file system, and then we can adopt the database as a PDB without doing any additional copies, right? We restore the data files, and then we adopted the PDB, keeping those same data files in place. So I didn't need any extra space for that. If you are going to an ASM location, obviously, it will be probably more clear when we go to that part of the process. When you do a restore, you restore the data files as LVM, as file system as they were before, and then you adopt the PDB. You need to convert those. So basically, you are copying the blocks from those LVM files to the ASM disk space. So you need. If you do that, you need that extra space, but then you will have all the advantage of having the the ASM. And again, if you're going to access Data Cloud Service, you have to. Okay. So again, if it's a small database, a test database, if it was LVM, you can just keep it LVM and go with that. If it's something you use it for production, it's a larger database. You want to have all the flexibility of having ASM, maybe maybe you go to Exadata, maybe you're going to use RAC, etc. Then you better go to ASM. Okay.
Fantastic, thank you. Go ahead. Keep going.
Okay, no problem. Yeah, I think feel free to stop me later if there are other questions. Okay. Thank you. So once we've done this, again, the backup is started, and when it's completed, you can use this command to find out what the actual backup pieces are that were created by this backup time. That is this command that you can use to list the content of the backup directory of the backup application that we created before, and you will see you have a list of file names, which are actually the block. The backup sets, the backup pieces that we're going to copy for restore. There is another option here that I didn't mention in this case, but you will find it in the documentation. It's p_label. It gives you the option of having a specific label attached in front of this file name. This may not be necessary if you are doing this, so basically creating a completely new backup location, completely new bucket that is only used for this purpose. So it's empty. You don't need to specify a specific label. You just copy everything because you know that everything is in there is what we need because everything is created by this backup. If you take subsequent backups going to the same location, you may want to use it to differentiate those backups from this one and have it easier access to them. Okay. So at this point, we have a full backup, including archive logs of our database on disk on that location, on that backup location. And as I mentioned, we have to then copy this backup to an S3 bucket. And you do it using this select command. Again, this is not a PL SQL script that you run with the exec command. It's just select that you run on this RDS admin S3 tasks upload to S3 object. You specify the bucket name. So this is the destination where you want to copy your files, and the directory name, which is backup, which is the source location. Okay. All it does is basically say, copy everything from this backup location on the local disk to the RMAN-database-2. It was the name of the bucket I used. Whatever bucket name you used when you created the bucket is what you have to use here. Okay. I left the other things blank or empty, how you say, put them blank. This, again, means copy everything. Okay, everything is copied there, and don't change the names. The same name that was used on the backup application local disk will be used as a object in the bucket. You can change this if you want. For example, as I mentioned before, if you use a label for your backup, you may want to specify a prefix here to copy only that backup. And again, I will mention later why this maybe did it, although I didn't do it. So if you only want to copy certain files, you can specify here what the prefix of those files is. And the S3 prefix is if you want to add a prefix to the names of the objects when they are copied in the S3 bucket. Again, if it is a new empty bucket, don't care about that, you don't need it. Okay. The result of this select is a task ID. Okay. This task ID can be used to check the result of this copy process. If a very large database, it may take some time to do that. So you can use it doing a select on this table, which is in the bdump location. Okay, this is not the backup anymore. The bdump location is the default location where all the log files are written by AWS. So you read the file, the log file that has this name, the DB task ID returned by the previous query. Sorry, it's DB task dash the DB task ID returned by the previous query .log. And this will basically list the content of this log file, which is the log file created by the copy process from the local disk to S3. Okay. And again, here you have the link to the AWS documentation that explains. If you don't want to do the select and you want to just look at the console, you can also do that. And on the console, on the AWS console, you can monitor and verify both your RMAN backups and the S3 copy process. The RMAN backup log is here. So you go to the RDS console, you select the database, and when you select the database we are copying from, you have the logs tab. You click on the logs tab, you go to this events and logs tab, you go to this screen. On the log side, you can filter by RMAN. Here in the logs, and this is the bdump location I mentioned before, you have all the logs. You have the alert logs, you have all the traces from Oracle, everything. So you have a lot of files in there. You just filter using RMAN, and you will see these are the RMAN outputs. Okay, so this is the output of the RMAN commands for your backup. You just select the one you want and click on view, and you will actually see the RMAN execution output. If you instead want to look at the S3 copy, you will also find it here. In recent events, you see you have the task with the task ID that was the same task ID returned when you executed the select. They actually started the process, and you see upload to S3 started, upload to S3 completed, we started succeeded. So we know that we can control from here that our backup was run successfully and everything was done properly, and you can control from the recent events view that the copy to S3 was completed successfully. So at this point, what we have is a complete full backup, including archive log, in an S3 bucket. Okay. If you want, you can also get a list of all the backup pieces from the $V backup views that are basically the RMAN views on that are created by RMAN when you do a backup on the database. So you can run this select from this view, and you get a list of the backup pieces that were created by our backup. Here, by the way, you can also see the location, the actual directory that was created when we ran the command to create the backup destination. So backup is a kind of logical name. This is actually the physical name, but we don't care again because we don't have access to the operating system. So all we did was use the backup name and use the commands that we have available. Make a note and copy those backup piece names or handles that they're called on a notepad. We will need them later. Okay. So as I said, we have our full backup in RDS and in S3, and we are ready to copy it to OCI. You can follow the instruction. I don't go to all the details, but in short, we're going to use the rclone tool. That's what I used. You can use whatever you like, but there is a blog post here you can reference to in the MAA blogs that explains how to copy an AWS backup from AWS S3 to OCI. You copy all the content, and that's what I did, everything from that bucket to a new bucket in OCI. Okay. The next step we will have to do is, well, disable, in case you enabled automatic backup when you created the DBCS instance, our target instance, disable them for now. We will enable them at the end. And install the database backup cloud module. This is also explained in this blog post, that we install the database backup cloud module for OCI on the OCI instance. And in the following part of this presentation, we will use as example this library name, Home Oracle OCI lib for our library name, and this database-2.cfg OPCP file, configuration file. I don't go through all the process of installing the backup module, etc. But for those of you familiar with it, again, this is plain here in this blog and also in the documentation. But those of you familiar with it, these are the names that we're going to use. This is the library location where our SPT libraries will be stored, and this is the configuration file where the installer, the Java tool that is used to install the database backup cloud module, puts all the configuration file, our the wallet location for the authentication that we create. It puts the endpoint for our cloud, OCI cloud location, object storage cloud. And it will store obviously the bucket name where we are going to copy those files, and from where we will restore them. One thing to consider is that although this is a very valid description of how to do that, this was done assuming that the content of the AWS S3 bucket was already an RMAN backup created directly to the bucket using this SPT interface. So it's already an RMAN cloud backup, if you will. In our case, it's not a cloud backup. It's a backup that RMAN wrote to disk, and then we copied it to object storage. So from an RMAN perspective, the format of that backup is an RMAN disk backup. It's not an RMAN cloud backup. So for being able to restore it from the cloud, we need an additional step that I will go through in a moment. Right? And obviously it's not part of this blog because we assumed in that blog that we were copying backups taken directly to the S3 bucket using, for example, the Oracle Secure Backup Cloud module for S3. Okay? That it is possibility if your instance in AWS is an Oracle database running in compute instance that you installed and managed completely. In that case, it's possible you have installed the Oracle Secure Backup Cloud module in it and you're backing up directly to S3 already. Great. It's easier at that point because obviously all you have to do is copy that backup to OCI. You will go straight into the use case of this blog post. You have an RMAN backup in S3 that was taken directly by RMAN right into the bucket using the Oracle Secure Backup Cloud module. It's ready to be restored by RMAN using the database backup cloud module. The format is the same. But in this case, we are using RDS instance. We don't have access to the operating system. We can install the OSP cloud module to back up to S3. So it's an RMAN to this backup that we have to convert. So at this point, we go ahead and start the preparation for the store, and this is what we did. Okay, we created a temporary instance, so we restored it as a new temporary instance because this is a non-CDB database in RDS. So we have the conversion to do. You cannot restore, right, in DBCS and use it as a DBCS database because it's not a PDB and it's not encrypted, and we need that. So we use the RDS database seed. We set the Oracle seed environment variable as that RDS. We started RMAN, target / startup no mount, and so we basically started this dummy instance. Okay. preparing for a store. We set the DBID equals to the DBID in RMAN at this point, equals to the DBID of the source database, so the RDS database. You can find it if you don't remember it. You can find it here, the C- backup piece. This is the control file or the backup that we copied over. Remember, I suggested you to store to know this backup piece handled somewhere. So you will have the C- something. Okay, this is the DBID. So we set the DBID equals to this ID, and then we have to do that additional step I was mentioning. It's documented in another different location that it's linked here, but the point is, we are in RMAN, we start a run block, we allocate the channel, and when allocated the channel, we specify the SPT library that I mentioned before when we run the database backup cloud module installer. We use this library location, so this is the SPT library we're going to use, and this is the configuration file that we specified when we run the database cloud module installer. So we run this, so we use this configuration file, which basically, includes the name of the bucket that we use to copy the backups. And we send this command, which is export backup piece name, the backup piece name. And we do this for all the backup pieces that we noted from looking at the source side.
Hey, Marco.
Yeah.
Quick question is, Eric is asking, can the AWS DB backup directly to the OCI object storage using SBT?
You can. Hold on. If you have an RDS instance, no. Okay, so if you have an RDS instance, all you can do is use the tooling that they make available, as I mentioned before, those PL SQL script, RDS admin _ RMAN util, and the commands you have. And you can just take a full backup to this destination, and the destination is the local disk. That's what you can do. But if instead you are not using an RDS instance, but you are using a compute instance, where in AWS, so an EC2 instance, it's called, okay, it's a different service. RDS is the relational database service. It's a managed service where you just say, I want to set up a database instance, you specify the parameters. It's similar to our DBCS or XCS. Okay, but the main difference is that you don't have access to the underlying operating system in AWS. So you can only do what you can do through their tooling. So that's the relation database service we're talking about. If you're using the EC2, which is the compute service, and you have a compute VM where you installed Oracle and you managed it completely, it's not managed by AWS, it's you, then obviously you have access to RMAN, and in that case, you can do whatever you like. You can install the database backup cloud module, or you can install and point it directly to an OCI bucket if you want, if you have a network access to it, or you can use the OSB cloud module for AWS and point it to an S3 bucket and back up directly to the S3 bucket. In that case, it's possible, but in that case, you would be managing your database, and it would be in EC2, not in RDS. So it's a different use case. Okay.
Great, thank you so much.
Okay. So you run this export backup piece command through the send channel and RMAN. This will basically convert the format of these backup pieces stored in the OCI at this point, because we copied them already in OCI, and convert them into cloud backup. So RMAN, we can restore from them directly. Okay? It's not actually converting the format of the files, it's just adding some metadata files. Okay, so you will see that when you copy this, there are no XML files in your bucket. If you look at the content, after you run this command, you will see there are some XML files in your bucket, one per backup piece. Those are the metadata files that are created by this process. But the point is, it's all needed so that we can use RMAN and say restore from this location without the need of copying those back into our block storage. So we're ready for the store, and at this point, this part becomes really kind of a regular restore of an Oracle database using RMAN to a completely new instance, right? So we are using this dummy instance that we started. You run this run block where you allocate the channel again using the same parameters, and then we restore the SP file. That's the first thing. We restore the SP file to temporary location and we specify the backup piece name of the C-backup piece, which is the control file or a backup taken at the end of our backup. So we restore the SP file from there. We do the convert, right, of the SP file to a P file, and we shut down this instance. We edit the P file, so this file that was restored, and there is an SP file in there. We can delete it. And then we look at the control file, data files, audit, and log file names stored and specified in this P file. And we change them, or that's what I did. I just created in the DBCS location the directories to specify here so that we can just do a restore directly. So I create the directories with the same name we had in the RDS side for the data files, create directories for the control files, and the audit log destination and the log destination on the local DBCS instance.
Hey Marco, sorry to interrupt.
Yeah.
Lorenzo one is asking, is that a PAS instance or compute IaaS we are restoring here?
On the source side, so if the question is the source instance, it's an RDS. So it's a relational database service instance. Obviously with an Oracle engine, the relational database service you can use other databases. Obviously, we're not interested in the Oracle engine. So it's an Oracle database running in AWS as an RDS, a relational database service instance. On the target side, I am restoring to a DBCS, so database cloud service instance. So I'm not using compute. There's not compute on both sides. On both sides, we are using database services, okay? RDS in AWS, DBCS in OCI. But for XSCS, it's the same thing. Only that you need to take care of the converting to ASM because you cannot leave it running on the local file system, but that's the only difference. We're using database services on both sides.
Awesome, thank you.
Okay. So we were preparing for a store. Basically, we create the location. Oops, sorry. We create the location for the control file, data files, audit log files. And we copy the P file that we just edited, and we copy it to the default location, if you want, for the instance that we're going to use for the store. Again, this is not a new instance that we will leave there. We're just using it to restore the AWS instance on the DBCS side. So we go to the Oracle Home DBS and we create the init state.ora file by copying this. And then we're ready to start up the mount. We pick up this initialization file by default, and we will start that instance with the same configuration. We don't care about the parameters of this SGA or other things or more detailed configuration because this is only temporary and needed for restore.
Hey, Marco, Rashmi is asking, was the export step equivalent to catalog step in RMAN?
No, that's not catalog. We will run the catalog later. This is just so that we can run this restore command. Okay, so the original backup was an RMAN to disk backup. It was not a cloud backup. So if we don't do that, when we do this restore SP file, and obviously also the subsequent one, but this one is the first one that we do. So the first one that would not work is because RMAN would not be able to read from this location, which is the cloud object storage location, and find this backup piece. Okay, because what we're doing here is we're locating a channel pointing to our bucket, basically, in OCI object storage. And then we tell RMAN restore this backup piece. And Arman would go into this bucket and not find this backup piece because the objects in that bucket are not in the proper format. The backup is not a cloud backup. So Arman expects certain things when it reads and writes to the object storage. Okay, so the format, this backup piece was taken to disk, so it's not in the proper format, and Arman would just say, no, sorry, I don't find this backup piece in this bucket. This is because those XML files are missing. The expert backup piece, what it does, it creates those XML files. So when now we go and tell Arman restore from this backup piece, Arman would look into the bucket and finds it because it finds everything it needs.
Also, Curtis is asking, can we see the contents of the database-2.cfg file? Do you have that by any chance?
I don't have it now, but I can. If you have time, I can log into it and show it. But it's a very basic configuration file. Again, this file is created when you run the installer. So if you look at the blog post I mentioned before, if you look at the documentation on running the database backup cloud service installer, the database backup cloud module, then you specify the configuration file. The configuration file is created by the installer. Okay, so you don't have to edit it, but you can look into the content if you want, and it's a very simple configuration file. It has the endpoint, so it will have object storage dot https column / object storage dot region dot oraclecloud.com. It will have the wallet location that is specified again when you run the installer. The wallet location is where the installer stores the authentication information, so it can log into a bucket and read and write to it. It will have the bucket name in it, and that's pretty much it, unless you add anything else particular. So it's a very simple configuration file. Yes, I hope that answers the question. So again, we at this point we do the restore. We're able to read from the bucket that was in the previous question, right? So next step, we do startup mount, and we're ready to restore the control file. Similar as we did before, we allocate the channel pointing to the bucket. We do restore control file from the same control file or a backup piece. And once that will go into default location that we created, we will prepare for based on what's in the initialization file here. And then we're ready to do a startup mount, okay? And we will have our instance temporary instance in mount mode. We can, if we want, do a configure channel because we have the control file mounted now. So we can do a configure channel and set both the SPT library and the configuration file stored in Arman, so we don't have to use the run block and specify the allocate channel every time. And we can also configure the default to SPT tape if we want. These are optionals. If you want to just keep using the run block and explicitly allocating the channels every time, you can do it as well. And now this is a step where we do the catalog backup pieces. Okay, so we cannot skip this part. We do the catalog device type SPT backup piece, and again we install the backup pieces that we noted. Okay. This will store the information for these backup pieces in the control file. And then what we're going to do, we do a cross-check backup and delete expired backup. So we remove entries of the original AWS disk backups that are still in the control file. Because if you remember again, I think I mentioned 3 or 4 times so far, the original backup was not a cloud backup, it was a disk backup. So the information stored in the control file that we just restored about that backup is that it was a disk backup. Okay, now we don't have those backups on disk, on block storage. The backup is in object storage only. And so we do this cross-check and this delete expired backup. So basically we remove those entries for those disk backup from the control files because Arman will not find them anymore. And it will still find this that we just catalog. Okay, so we will have a consistent control file information about backups with what we really have, which is a backup in object storage in the cloud. And once it's done, we're ready to do the restore, the actual database restore. So we do a restore database, we do a recover until available redo, and our database is recovered. And we are ready to open it. So we do an alter database, open reset logs, statement process, our database is restored and open. So now we have a database restored from AWS in DBCS, but that's not still a valid DBCS database from an Oracle Cloud perspective. It's not a PDB, and again, both XSCS and DBCS must be in a multi-tenant format, and it's not encrypted. So it's two things that we need to do more. So we can shut it down, basically. We don't use it. We just open it and make sure it's working, it's valid. So we shut it down. And next step, we prepare to adopt it as a PDB. Okay, so we start up in read-only mode. That's why we shut it down. So we start up in read-only mode, and we run the describe command to create the manifest file from the non-CDB. This is again a standard procedure for converting a non-CDB Oracle database to a PDB. And it's described in this MOS note that I pointed to here. Okay, it refers to 12c, but the process is exactly the same for 18 or 19. So you run the PL secret script to create the manifest file, and then we can shut it down. Now we have the manifest file. We basically connect to the actual DBCS instance. So we close SQL+, we reset the Oracle seed back to the original Oracle seed for our DBCS environment, or we can log off and log on if it's easy for you, the Oracle user, and then you start SQL+ connected to the actual DBCS database, the actual DBCS instance or XSCS instance, whatever you're using. The first thing we need to do when we're doing this non-CDB to PDB process is analyze the compatibility, I think it's right. And so we run this check plug compatibility build secret script specifying the manifest file that we created in the previous step, the manifest file from the RDS instance. And then we run the select on this object, I think it's a view, with this weird name, PDB underscore plug underscore in underscore violations. When name equals, I mean, you can even omit this part if you want to make sure you're only looking at the violation for this PDB. You specify, you know, this the name of the AWS instance, and we have to check that, make sure that everything is ready to be imported. Otherwise, you will not be able to do it. So the result of this script is a series of warnings or errors. Okay. In general, some warnings, or I would say all the warnings can be ignored. Most of them will be about table spaces not being encrypted. Obviously, we know it. We will encrypt later, so we ignore that for now. That can be warnings for option mismatch. Those can also be ignored, as all of them will probably be that option XYZ is present on the CDB, but not on the PDB. Because again, on OCI, we have all the options active on the databases. In AWS, you don't. So these warnings will tell you, okay, yeah, option whatever is on the CDB, but not on the PDB. As long as that's the case, so it's an option that is in the CDB, but not on the PDB, you can ignore that. It's okay. You may have another warning, which is the time zone version file violation, and I found that one that cannot be ignored. If you don't have the proper time zone file on the CDB, you cannot open the PDB. So that's a warning, but it must be resolved. In my case, I had version 34 in RDS, and for some reason on the Oracle side, I only had time zone file version 32. Okay, but it's very easy to solve it. You go to MOS, you do a search for time zone patch file version 34, you find the patch, copy it to the DBCS instance, install it, and you're good. Okay. There may be other patches. For some reason, you may not be going to the latest version like I did. So you may have the patches that you need to resolve. If the patch is present on the PDB, but not on the PDB, again, you have to do it. All you have to do is install it. So go to mass node, look for that patch, the output of the select you had, so the violation that is result on the view will tell you what patch number it is. So you go to mass node, search for the patch number, download it, install it, and you're good. So once you've done that, you can just run the create pluggable database name, the name you had it in AWS, using the XML manifest file that we created. Just said copy. This created at DBCS. It leaves the data files where they are. If you are in a situation where you are going to XSCS and you're coming from an LVM instance, you want to specify a different location. Here, you have to specify different. I mean, you have to go to the ASM. Then you can specify here a file convert option, and so this will create the PDB and also convert the file, and so copy it to it, and the ASM location, for example. And then you can do an alter database alter pluggable database open, and that's more or less it for this part. If the database, if everything was resolved, you don't have other issues, you didn't have patches that needed to be installed or things like that, this will be open in read-write mode, and more importantly, not in restricted mode. So if you do a show PDBs command, you will see your new PDB, and you will see it's open under restricted. You see no. Okay, so if that's the case, I think we're running out of time for additional questions. If that's the case, you just you just ready to go basically, and you can go to the next and last step, which is the encryption part. If it's open and restricted mode, you can query the violation view again. It will tell you what's wrong, and more likely is that some of the you had some patch errors here. You installed them. There is another thing that you have to run, which is the data patch script. This is an operating system script. So you exit SQL Plus, you run this data patch -verbose command on the operating system level, and this command will basically find all the patches and install them in the PDB. It will update the PDB with the information that those patches are installed and available. And at that point, you should be done, and nothing else should be needed. You can go back into SQL Plus, do an alter pluggable database, open, read-write, and that should be done. Should be good. Nothing else is needed. If you're still having problem, there is a mass node exactly for this. It says, okay, I ran data patch, but I still have violation, and so you can look at this mass node. But you shouldn't have any. I didn't have any other problem after I did this. So I did my alter database, alter pluggable database. Sorry, missing the database name here. Open, read, write, and then that's it. Okay. If you were in one of the situations before, you would see pluggable database alter with warning or with errors or something like that. That you know that something is wrong and there's something else that needs to be done. If you do this and then you do a show PDBs, you see not a restricted mode, you're good. So the last thing we have to do is we have to encrypt it because it's mandatory that it in DBCS or XSCS, so the database are encrypted. And to do that, we connect to the PDB and we create the master key. That's what we're still missing. So you do an order session set container equals the PDB name, and then you run the administer key management set key using tag, whatever tag you like. Force key stored identified by password. This password is the wallet password, but it's the same password that you use as an administrator password, which is the sys user password when you created the DBCS instance. The same password is used for the user and for the wallet. So you specify the password here with the backup using, and you give the backup a name. This create a backup of the wallet before making changes. So key store altered. So your master key is created. You're ready to do the encryption. And again, there's nothing weird here to do. You just do alter table space. I started from system. You had to do it for all of them. Encryption online using AES 128. I use AES 2256. What encrypt, and That's it. It will do an online encryption of your table space. You do this for all your table spaces, and then you're done. You're good. You physically migrated your RDS database to DBCS or XSCS. You adopted this as a PDB in DBCS or XSCS. You have encrypted it, so you're in a fully, compliant situation for a DBCS or XSCS database. And we did it using a physical migration. Okay, there is a service in AWS. It's called AWS Data Migration Service. That's an alternative approach if you want to migrate your database to OCI. But that's a logical migration. So it creates a new database and just logically then create the schema, create the tables, and copy logically all the data from one database to the other. It's more complicated. I mean, at least I found it more complicated to set up. You have to set up as a new service in AWS. By the way, is also, it has associated costs. It's not a free service. You have to pay. You have to pay for it when you run it. You have to set up additional instances in AWS. So yeah, I found that in many situations doing the physical migration is more straightforward and easy, especially if you're familiar with RMAN. You will find that a lot of the things I did is really regular RMAN restore. Adopting a PDB is a regular process if you're familiar with it. So you may already have a lot of the concepts that I explained here. We already covered this because it was asked before, but in my case, I went from an LVM environment to an LVM environment. So just file system to file system. If you're going to ASM, yeah, you can use file name conversion. You can do it, as I mentioned before, when you adopted PDB. If you want to do it in advance, maybe it can save space. You can also change when you do the restore, you can restore to a new location. So you can do if you want conversion from file system to ASM, either at the ALMA restore time or at the PDB adoption time. It's probably easier doing it at the PDB adoption time, because if you do at the SM conversion time, you will also have to take care of all the location that we change in the configuration file in the init.ora need to be changed so that we can start the instance in ASM. It's easier to just restore the instance as it was originally. That you don't do that conversion for something that you will not need later, because once you're done, once you adopted it as a PDB, you're done. You don't need anything else.
Hey, Marco, real quick.
Yeah.
If RDS is encrypted, how do we transport the keys?
As I mentioned, if RDS is, again, you will see it encrypted, but most of the time when they say encrypted, it's storage encryption. It means that it's so when we read the backup and we write the backup, it's not encrypted in RMAN, and the database itself was not encrypted using TDE. Okay? So if you see that type of encryption, you don't have to worry about that. But if you use TDE encryption, and you would know it because that is something that you have to do explicitly using command lines and using the tools that similar to what I showed you before, the RDS admin tools, then you would know your database is TDE encrypted. In that case, you may have a problem for doing this because you don't have access to the wallet. In that case, you don't create the wallet, you don't create the master key like I did when I did the encryption here. It's done by the RDS automation. You don't have access to it. So you cannot extract the encryption key. You cannot copy the wallet somewhere else. So what you have to do at that point is clone the instance using the RDS tools. You clone the instance, and then you disable encryption. Again, you disable encryption, and then you basically go through the process again. You disable TDE encryption. So you go through the process I just described, which is basically copying a non-encrypted, non-TDE encrypted database.
And logical migration should be used, Rashmi added.
That's another option. As I said, that's another option. You can use logical migration in that case if you want to use it. But again, it's something you have to set up and you have to pay for. But if you want to go to that, that's also a valid approach. Okay.
Awesome. Thank you, Marco. I think we are out of time. So,
yeah, unfortunately. Yeah, but we covered the questions as we were going. So
yeah,
we
no
covered all
worries.
of them.
This is great. Thank you very much, Marco. I really appreciate it. Thank you, everybody, for joining us today. Look for us in May for our next topic on our database cloud services. And if you have any requests or any kinds of topics that you'd like to hear, please do reach out to myself, tammy.bednar@oracle.com. Would love to hear from you on what you'd like to hear. So until next time, have a great month. Everybody stay safe out there. Bye now.